Hello and welcome back. Today we are going to address some word problem which lead to the quadratic equations. I have taken some examples from 8th edition of D3 and these problems belong to exercise 2A. Let us start with it. The first problem states the sum of a whole number and twice the square of number is 10. Find the number. So in such cases, first we have to suppose the number. Let it be x. Then according to the given condition, the sum of whole number and twice the square of the number is 10. So it will be x plus 2 times x square equals 10. That is the primary equation made from the statement. And because this is a quadratic equation, we have to change it into the standard form by writing the quadratic term first, then its linear term, and then constant. From the right hand side to left, it will become minus 10 equals 0. Now because it is a quadratic equation and if it appears in P1, then we have to solve it with the factorization method, otherwise we can use the formula as well. So we can first factorize it, it will become 2 times minus 10 becomes minus 20. So we are looking for the factors of 20 whose difference is 1 because middle term the coefficient of x is 1. So they will be surely 5 and 4. We can write it as 2x square minus 4x plus 5x minus 10 equals 0. Now we can take commons, it will become 2x times x minus 2, then plus 5 times x minus 2 equals 0. Once again we can take x minus 2 as common, x minus 2 times 2x plus 5 equals 0 because the product of two numbers or two factors is 0. One of them must be 0, so we can write either x minus 2 0 or 2x plus 5 equals 0. The values of x coming are x equals 2 and x equals minus 5 by 2, which cannot be the value because it is a negative number as well as it is a fraction, that's not a whole number. So the value of x is 2, thus the required number is 2. Coming to the next question from the same exercise, it states the two consecutive positive numbers are such that the sum of their square is 113. Because it said the consecutive numbers, consecutive positive numbers. So first we have to suppose the numbers. Let's say p and p plus 1 or p minus 1 be the numbers. Here we should clear something, that when it say consecutive numbers, then the numbers differ by 1. Either if one of the numbers is x, the next could be x plus 1 or x minus 1. But when it say consecutive odd numbers or the consecutive even numbers, then there is a difference of 2. So if we take one number x, other will be x plus 2 or the x minus 2. So here are the consecutive numbers, so we can suppose it by the difference of 1. So the conditions say that the sum of their squares is 113. We have to find the numbers. So sum of their squares, first number square and then added to the square of second number p plus 1 whole square equals 113. So first we have to expand this whole square. It will become p square plus p square plus 2p plus 1 is equal to 113, and that because it is a quadratic equation, we have to change it into standard form. So it will become 2 times p square plus 2p plus 1 minus 113 equal to 0. The right side must be 0. Now after we simplify it, we get 2p square plus 2p minus 112 equals 0, and that can be simplified by taking 2 common. It will become p square plus p minus 56 equals 0. Once again, the product 2 can be moved to the right hand side and it will be divided by 0. P square plus p minus 56 equals 0 divided by 2, which is eventually 0. So the equation now becomes p square plus p minus 56 equals 0. Now we have to solve this equation using either the formula or the factorization, and we will factorize it. Minus 56, we have to take its factors whose difference is 1 because the coefficient of middle term is positive 1. It could be 8 and 7. Their product is 56 and their difference is definitely 1. So it will be p square plus 8p minus 7p minus 56 equals 0. Now the factors will become, I'm taking it a step ahead, it will be p plus 8 times p minus 7 equals 0, and it gives us p equals minus 8 and p equals positive 7. And as it said in the question that the numbers are positive, so negative minus 8 is rejected. So our one of the numbers p is 7. So the next number, which was p plus 1, should be 8. Thus 7 and 8 are the required numbers. Let us address the next problem from the same exercise, which states the difference between the two positive numbers is 7 and the square of their sum is 289. Find the two numbers. Because the difference between the two numbers is 7, so we can suppose the numbers by the difference of 7. Let x and either x plus 7 or x minus 7 could be the second number. Then according to the condition which states square of their sum, so first we need to add them, x plus 7 and its whole square, it equals 289, which will become 2x plus 7 whole square, it equals 289. Now because 289 is a perfect square number and the variable appears in the square only, so we take the square root to cancel the square and simplify it in 2 or 3 steps only. So we can apply the square root to both sides. It will become 2x plus 7 whole square equals plus minus the square root of 289. So on the left hand side, square and square root will cancel out. It will become 2x plus 7. It equals plus minus 17, which is the square root of 289. Now solving it in two different equations, one with 17 and other with minus 17. 2x plus 7 equals minus 17. In the first we will get 2x equals 10 and x will be 5, and in second we will get 2x equals minus 24 perhaps, and x will be minus 12, which will be eventually rejected because it stated the numbers should be positive. Thus, if one of the number is x, other was x plus 7, so it will be 12. These two are the required numbers. In next part it states, if 4 times a whole number is subtracted from 3 times the square of number, the result is 15. Find the number. Once again we have to start with the assumption, let x be or the y be the number then according to the condition which states 4 times the whole number is subtracted from 3 times the square of number. So it will be 3 times y square minus 4y and result is 15. Once again that is a quadratic equation, and in case of quadratic equation we have to change into standard form 3y square minus 4y minus 15 equals 0. We will start factorizing it by taking the product of the coefficient of y square and the constant. So it will be minus 45. We are looking for the factors of 45 whose difference is negative 4, and they are surely 9 and 5. 9 times 5 is 45 and their difference is 4. So it will become 3 times y square minus 9y plus 5y minus 15 equals 0. Once the factors become y minus 3 times 3y plus 5 equals 0. Y gives us values y equal 3 and y equals minus 5 upon 3. Minus 5 upon 3 being a fraction or not a whole number will be rejected. So the required number is 3 definitely. Now here is a little task for you. Solve this question and try to write the answer in comment box. I will reply to your answer and see you in the next video.